Hello everyone. Today we are going to start a new chapter which is the periodic table class 9. Myself is Suman Singh. So in this chapter what we have to learn? We have to learn the general idea of Dominus triad, Newton law of octave, Mendel periodic table, okay? And the discovery of atomic number and the use and its use as a basis for the modern periodic law, okay? After that we will learn about the modern periodic table, and after that we will learn about alkali metals, alkaline earth metals, halogens and zero group, okay? So first of all, when we talk about the introductions of this periodic table, so we know that we human beings have always put the things of one kind in one group, okay, and another kind in another group, right? So towards the end of the 18th century and the beginning of the 19th century, what happened at that time, more and more elements has been discovered, okay, and the scientist was learning each and every elements, and the scientist was doing an experiment on each and every element to know about its chemical and physical properties, okay. So they realized that we should develop a system in which we can place this all the known elements which were known at that time, all the known element with their similar all the known element in a systematic group, okay, or in a systematic column, so that we can study that element in one go, okay. So as you can see, it is written here, towards the end toward the end of the 18th century and the beginning of the 19th century, more and more elements began to be discovered, right? And their individual properties and compound have begun to be studied. Soon the need arose for classifying them so as to make their comparative study easier. To study them easily, what they have done, scientists has started to classify, or we can say that adopt a method through which we can classify this element so that we can study that element comparatively, or we can say that more easily, right? So what was the reason behind the classification of the element? So first reason is it help in studying the element in an organized manner. Means what, if we will classify the element suppose according to their group, nowadays it has been classified according to their group and period, right? So we know that in a group, when we talk about the group, suppose we take the first group, which is lithium, sodium, potassium, right? That's group. Or we can say that the halogen group, which is fluorine, chlorine, bromine, iodine and astatine. So whatever the properties the fluorine will show, the same properties will be shown by chlorine also, bromine also, right? So nowadays we have developed that method from which it has become very easy to study the periodic table or study the elements, right? So what will have, why it has become easy? Because we have systematically arranged the element, right? So as you can see, it will help in studying the element in an organized manner, right? Now next is, it helps in correlating the properties of the element with the fundamental properties of all states of matter, as I have already given you the example, right? Say for example, you can take the example of the inert gases just like helium, neon, argon, krypton, xenon and radon. They all have a similar, or we can similar property, or we can say that we can correlate their properties of that element, right? And we can study them more fundamentally. Now next is, it help in defining the relationship of one element with other. So it will also help us to define the relationship of one element with another, right? So this was the need, this was some of the points which tells us that why there was a need to classify the elements, right? Now in the beginning, the attempt was made by so many chemists, okay, and on the basis of that, some of them has tried to classify the element according to their physical properties, just like density, malleability, ductility and all, right? And also some of them had tried to identify, or we can say that classify the element into a group of metal and non-metal, right? But none of this method, which is called physical property, or this metal and non-metal concept, has proved to be satisfactory, because when you will see that the number of element falling in a particular group were so large that it did not serve the purpose for generalization. Okay, when we talk about the sorry when we talk about the density, malleability, and ductility at that time, the number of elements falling in a particular group was so large that it did not serve the purpose for generalization. Okay, now next is some of the characteristics being considered varied with different condition. Means some of the properties, when we have seen, the scientists have seen that just like ductility, density, and all, so that property used to vary with the change in time, or we can say if there is a conditions is different, the properties will change. If we will change the conditions, then the properties were changing, right? So this was also the second factor which does not found to be satisfactory for the classification of element, right? Now next is certain metals, so metallic as well as non-metallic characters both, so that is why we cannot classify them into metal and non-metal also, because so many metals are there. We will learn about that. So many metals are there, or we can say metalloids. We call them as metalloids. They will show both the properties of metal as well as non-metal, right? So I hope you have got some idea about why there was a need to classify the element, right? Now obviously scientists were searching for characteristics of the element, right? That will never change. So what was the need of the scientists at that time? Scientists were identifying that there should be one property in every element which will not change with the conditions, or we can say it will not change with the change in time, or we can say if you are changing the temperature, pressure, or anything, it will not change, right? So it in this search, one scientist named William Proust, first of all, he discovered atomic mass, concept of atomic mass. Okay, and what he told that the atomic mass of the element will never change. Okay, as you can see, it was it was William Proust who discovered that the atom or the atomic mass of an element never differ, and that it could therefore form a truly scientific basis for the satisfactory scheme of the classification. When Proust has discovered that atomic mass of the element of never differs, right, or never change with the conditions. So what happened next is we have taken his concept of atomic mass, and this concept of atomic mass has found to be satisfactory for the classification of element. Okay, so now we will see one by one. First classification is made by Dobiner. Dobiners, okay, J.W. Dobiners. He was a German chemist, and what was his observation? I will give you a short uh, explanation on that. He told that atomic mass of the, suppose there are three elements, 1, 2, and 3. Okay, 3, 2, and 1. So according to the Dobener's triad, the atomic mass of the middle element of the triad, suppose this is the middle, right? The atomic mass of the middle element was approximately equal to the arithmetic mean of the atomic mass of the other two element of that triad. Suppose its atomic mass is x. Let me change the color. Suppose its atomic mass is x and its atomic mass is y. So what will be the atomic mass of this 2? The atomic mass of 2 will be x plus y divided by 2. Right? I hope you have understood this, right? So he told that the atomic mass of the middle element, this one, the atomic mass of the middle element of the triad was approximately equal to the arithmetic mean of the atomic mass of the other two element of that triad. Suppose if the atomic mass of this is x and this is y, so its atomic mass will be his atomic mass will be x plus y divided by 2, right? So now we will see from the book. So J.W. Dobiners, he was a German chemist who observed that the certain element display a similar property, and they could be placed in a group of three element each, and this group of three element each were given as a name of triad. Okay, so what was Dobinur's observation? He observed that some of the elements, when you will place them in a group of three, okay, they will show similar property. Okay, they will show similar property if we will place he observed that if we will place some of the certain elements in a group of three, so they at that time they will show as similar properties. That that group of three he has given the name as triad. Okay, now next what he did, next was what he did was the three element, okay, of a particular triad, the three element of a particular triad had a similar chemical property, as I have already tell you. Okay, in fact Dobinus was the first scientist to show the clear relationship between the properties of the element and the atomic mass. Okay, so Dobinus observation was that if we are arranging the element in order of their increasing atomic in a group of three, then they will show a similar property. Okay, and the Dobiners tried, or we can say that Dobiners was the first scientist to show a clear relationship between the atomic mass of the element and and their properties. Okay, now what is the definition for the Dobinus triad? We can define like this. According to the Dobinus triad, the atomic mass of the middle element of a triad was approximately equal to the arithmetic mean of the atomic mass of the other two element, that is called triad. Okay, so I hope Dobinus triad you have got some idea, right? Now next was we will see with the example. Okay, just now we have seen with the x and y, right? Now we will see with the proper example. So the first of all what he has did, he has taken three elements, which is calcium, strontium and barium. Okay, these three elements are what? These all are metals. Okay, and when you will see is oxides, that is its oxides will be alkaline in nature. Okay, now next is when you will see its valency, each of them will have a valency of 2, right? So since they have a, we have seen that since these elements have a similar chemical properties, right? Because oxides, valencies and all, these are what? These are chemical properties, right? So since we have seen that these three elements, calcium, strontium and barium, have a similar chemical properties. Okay, so what Doveners has did, the Doveners has put together in one group. Okay, to form a triad called Dovenus triad. What he did, since he has shown that he has all are metal, their oxides are alkaline in nature, they have each of them has a valency of 2. By seeing this chemical properties, Doveners has decided to put together these elements in one group or a family, which is called which he has given the name as Dovenus triad. Okay, so when you will see the calcium, okay, strontium and barium, let me write it clearly. Calcium, strontium and barium. Okay, calcium has atomic mass which is 40. Okay, and barium has atomic mass 137. So what he, how he has found out the mass of this element strontium? He has added these two. So when you will add these two, what we will get? 7 4 7 and 107 177, right? And it has been divided by 2. So what we have got, as you can see, barium has 40 and it has 137 and it will be divided by 2. So 177 divided by 2, which is 88.5. So the this is nearly the same as the atomic mass of strontium, which is 88, right? So in this way he found out that if we are arranging a group of elements in a group of 3, the atomic mass of the middle element is the arithmetic mean, or we can say that average of the other two elements. Okay, the example you have seen here, right? Now next example is with the non-metal. So it's taken three non-metals, which is chlorine, whose atomic mass is 35.5, and bromine 80, and iodine 127. What is the similarities between these three elements? The similarities is all of these elements are what? They are non-metal, right? Next is all react with water to form acids. Okay, now third is all have a valency 1, right? So these are the three similarities between these three elements. Okay, now so when we have seen the when we have calculated, so when we have added the mass of the chlorine and mass of the iodine, okay, mass of the chlorine and mass of the iodine, when we will divide by 2, we will get here 81.2, which is approximately the same as the mass of the bromine, right? So I hope you have understood this, what is Dovener's triad, right? Now what was the reason for the failure of this Dovener's triad? Because this we are nowadays we are using modern periodic table, right? So what was the need why these Dovener's triad were failed? So the first failure of this Dominus triad was Dominus failed to arrange all the non-element in the form of triad. Means all the elements which were discovered later on, or we can say that which were present at that time, Dominus failed to arrange all the non-element. Okay, there, because with the formula of this triad all the element doesn't fit in this formula of triad, right? So he failed there. Okay, now next is this law, the law did not fully apply even within the same family. Okay, when we will see the about the when we will see the family, nowadays we know na, halogen family, carbon family, oxygen family, alkaline. So this type of family, when you talk about the halogen family, so this law was not applicable on the in the same family also. For example, in the family of halogen family, you will see the oxygen family or nitrogen family, you will see that it was this law is not applicable to their family also, right? So example is given, taking the example of halogen. In a halogen, what was that halogen? It will be fluorine, chlorine, bromine, iodine. Okay, like this. So you will see that fluorine has atomic mass as 19, chlorine is 35.5, and bromine is 80. So when you will divide this fluorine and bromine, when you will add the atomic mass of bromine and fluorine, and when you will divide by 2, we will get 49.5. But we know that the chlorine has an atomic mass of 35.5, right? So this was some of the drawbacks of Dominer's classification. Okay, so what we can say, Dominer's scheme of classification of element was not successful, though it did not contain important instant and principles. So I hope you have understood this, right? So now keep up to this. In the next class we will discuss about the Newland law of octave. Okay, till that try to go through this chapter. Okay, so in the next class we will discuss Newland law of octave and Mendeleev periodic table. Okay, till that, thank you.